According to the law of definite composition, the composition of any pure compound is always the same. No matter how much mass you weigh out, no matter what, a pure compound is always going to have the same percentage of each element in it. So that's our purpose today, to determine the chemical formula of magnesium oxide by calculating the percent composition of magnesium and oxide in our sample. We'll also be determining the chemical formula from the mass of the elements, and we will learn how to write a balanced chemical equation. So how do you determine composition? First, you're going to take the compound and break it down to its elements, getting the mass of each element. Then you can use those masses to determine the percent of each element that makes up the whole compound. So for this experiment, we're first going to weigh out some magnesium in a crucible that has some sand already in it. We'll then convert the magnesium to magnesium oxide by heating it with a Bunsen burner. So this will be our setup that you'll see in the video. We have our crucible on top of a clay triangle, and then underneath that we have our Bunsen burner. Notice how close the Bunsen burner is to the crucible. We're going to use a very high heat to heat this magnesium because we want to convert it all to magnesium oxide. And you'll notice in this picture too that the lid of the crucible is not fully closed, but it is covering most of the top of the crucible. And this is because magnesium actually is very reactive when you heat it in the presence of air. So you can see that picture there. That's what will happen if it gets too exposed to the air while we're heating it. So we don't want a huge flame coming out of our crucible, so we're going to partially cover it. And then in the end, after we've heated it all to magnesium oxide, we will get a white powdery substance like you see in the second picture there. And just a note, air contains more nitrogen gas than oxygen gas, so we could be forming some magnesium nitride just from heating it in the air. So we're going to add some water to the magnesium nitride, and all of that water will convert the magnesium nitride to magnesium oxide, and ammonia will be a vapor that will come out of the mixture as well. Then after we heat it and add the water and everything, we will measure the mass of magnesium oxide after a few times of heating. Then we'll use this data to determine the percentages of magnesium and oxygen in the final magnesium oxide that we end up with, and then we will be able to find the empirical formula of the product. So the empirical formula is the chemical formula with the lowest mole ratio between the elements. And then you will also write down 2 other students' data that we will provide in the video. I know your report sheet says at least 5 students, but we have given 2 examples, so that is okay. So for your calculations, you will find the mass of oxygen in your final magnesium oxide sample, which is very simple. You have your final mass of magnesium oxide, and then you have the mass of magnesium that you started with, so you can subtract those from each other and get the mass of oxygen. Then you can use the mass of magnesium and the mass of oxygen to find the percentages of magnesium and oxygen in your magnesium oxide, which is also a very simple calculation. It's just the mass of one of those divided by the total mass of magnesium oxide you produced, and then you multiply that times 100 to get the percent. Then you can also find the moles of magnesium and oxygen in your final product, which is done by dividing the mass of each of those by their molecular weights. Remember, you can find the molecular weight on the periodic table for each element, and the units for that is grams per mole. So when you divide grams by grams per mole, you will end up with moles. Then you can use the molar ratio between magnesium and oxygen to determine the empirical formula of the magnesium oxide that you made, or that I made. And just a note, you can also do this in the reverse order. So if you have a compound that has a known formula to it, you can reverse this process and find the percent of each element in the compound. So if you know the formula, you can backtrack and say how many moles of each are in there, and then you can figure out how many grams of each are in there from the moles, and then the percentages from the grams. So just work it backwards to do that. Just a note about balanced equations. First, you're going to write the formulas of your reactants and your products. So just an example, if you say, I know that oxygen and hydrogen combine to make water, you can just write that out and say, okay, this is what I know. Then you have to think about the states of the matter of each of those. So are they solid, are they liquid, are they gas? Well, you know that oxygen is usually gas, hydrogen gas, and then water is a liquid, of course. So you're just going to add it just like that in parentheses, either a G, an S, or an L. So here we've added G's to the oxygen and hydrogen gas, and an L to the water. So you're going to add that as well. And then you can add coefficients to balance the number of atoms in the reaction. So a coefficient is just those numbers that are in front of each compound in the reaction. So you can see here, if you count the number of oxygens in the total reaction, there are 2 on the left side, as noted by the small 2 next to the oxygen. So there have to be 2 on the right side as well. So that's why we've added that 2, the coefficient in front of the water. So since we did that, now we've made 4 hydrogen atoms on the right side. So that means the left side has to have 4 hydrogen atoms as well. So that's pretty easy for this. We can just add a 2 in front of the hydrogen gas, and that will give us 4 hydrogen atoms. You will be doing this for your magnesium oxide, just making a balanced equation based on what your data gives you. So depending on how many, the mole ratio between magnesium and oxygen, you can figure out the formula of your magnesium oxide, and then remember to balance that equation and add the coefficients in front of the magnesium or the oxygen if needed.